Hi, and welcome to Jerry's Engineering Corner. My name is Jerry DiBattista. I'm the Global Vice President of Porex's Virtek PTFE Business Group, and welcome to my updated workshop. One question I get asked a lot is how our Porex Virtek compares to the new high reflective aluminum products that are designed for UV reflection. Those products typically are in the 80s% wise reflectivity versus 60s to maybe 70 for standard aluminum, so it is definitely a jump. Porex Virtek's products are all in the 90s up to 98%. So most people say, well, really, is there much difference going from something around 80% to something that's in the 90s? It's only 10% or maybe 15%. Well, today we're going to show how that effect is happening in a real life situation, and we're going to explain a little bit about Sumner's principle, which explains why a 10% or 15% increase is actually 2 to 3 or 4 or 5x improvement. So what we're going to do is we're going to take a closed box system. One's going to be in our Porex Virtek PMR10 reflective material. One is going to be in a leading, highly reflective UV aluminum. You can see it's super reflective and specular. And we're going to take a standard aluminum box, and we're going to compare using a constant UVC source. This is a UVC running at about 275 nanometers. And we're going to measure the output in one location to see what the average irradiance is within the box. First, I want to explain Sumner's principle a little bit more in detail. And what Sumner's principle says is that within a closed system, the total irradiance equals the direct irradiance plus the reflective irradiance. And as you can see from this chart, when you go down from low reflectivity of 30% up to 98%, the graph is actually fairly linear, so it doesn't really change very much. Slopes very, very low at the very beginning. So changes in reflectivity are not actually having a huge impact on total system irradiance. It's only when you get up into the upper 90s or the 90% is when it starts to really, really accelerate. So in this case, going from 30 to 40 to 50 to 60%, you may only get small increases, but going from 70 to 80%, you get a larger increase, 80 to 90 even larger, and of course 90 to 98, you get massive increases in irradiance. This here is a graph that shows the Porex Virtek average reflectivity over the UV wavelength. This is a highly specialized UV reflective aluminum, and you can see it has an up and down wave to it. So even within the peaks and valleys, you can get massive differences using Sumner's principle of almost 1 to 2 times just from the peak to a trough. And then down below is standard aluminum. And so what we're going to do today is, in theory, using Sumner's principle, going from Porex PMR10 to the highly reflective aluminum, you should see about a 2 to 4, somewhere between 2 and 4 times increase. And then from going from the standard aluminum to the Porex Virtek, you should have almost a 10x improvement. And here it is calculated out. We just started off with a direct irradiance of number 1. If it's 1 and the reflectivity is 60%, it should go up to 2.5, so it's a 2.5 times increase. If it's 1 and the reflectivity is 82%, you'll see it go up to 5.5, so that's about a 5.5 times increase from the 1. And then, of course, going to 8 or 94 of the Porex Virtek, it should go up to 16.7. So the differences here, as you can see, should correspond to what I said earlier, between 10x for the Porex Virtek versus the aluminum, and 2 to 4x versus the highly specialized UV aluminum material. Okay, so let's start the experiment. First, we'll start with the aluminum box. I just turned on the power supply, and the UV light is on. And then we will measure the irradiance coming out of the box in one spot. Sorry for it being upside down, but the sensor is on top. Let's get the light back on. So as it takes a few seconds to stabilize, so we're in milliwatts per square centimeter, I believe, and we're running around 34. So 34 for the aluminum. we are going to go to the high performance aluminum. So you would expect that this is going to go up probably 2 to 4 times. Let's see what the high performance aluminum gives us. See, it's still going up. Wow, not too bad. So it's stabilizing around 117. And now the Porex Virtek. You see it's still going up. Already over 200, 250. 286. 286. So, not sure if everyone was surprised with those readings. Didn't surprise me on how much better the Porex Virtek is. But 117 over 34, if you see the percent or the multiplier between going to the high-tech aluminum versus the standard aluminum is about 3.4x. And then going from the high-tech aluminum to Porex Virtek, 286, 117 is around 2.4x. So you see it's 2.4 times better. 2.4 times better than the high-tech aluminum, UV aluminum. So when somebody says it's only a 10% difference or a 12% difference, whatever it was, we calculate around a 14% difference. It's 14%, but in theory, you can get 2 to 4 times. In this example, it was 2.4 times the amount of energy within the system. And if you go from 286 to 34, that is 8.4 times. So 8.4 times more energy going from a standard aluminum to the Porex Virtek PMR10. Now we have grades that are even better. We have grades that are up to 98%, so you can actually increase that even more. So when you see something that looks nice and bright and shiny, it's sometimes not all it's made out to be. The Porex Virtek is clearly superior in reflecting UV light in a closed disinfection chamber. Well, that's it today for me, Jerry with a G.